This video demonstrates how to measure adjacent channel leakage power using the Anritsu MS2830A signal analyzer, which offers excellent dynamic range and phase noise performance. Let's begin with the wideband Cdma signal. First, we check the CCDF of the instantaneous signal power. Note how the CCDF of the WCDMA base station transmission signal approximates that of Gaussian noise, and pay particular attention to the large crest factor. The MS2830A makes it easy for the user to make accurate and repeatable measurements on standard communications signals. Selecting the target signal type from the main spectrum analyzer menu automatically sets the appropriate channel bandwidth, channel spacing, resolution bandwidth, video bandwidth, and detector mode for the target standard. This greatly simplifies the test setup and eliminates potential setup errors when making measurements. A critical measurement for wireless communications devices is adjacent channel leakage power ratio, or ACLR. ACLR limits are designed to ensure that the output signal from a device does not interfere with the operation of another device operating at an adjacent frequency, and they are typically very stringent. Accurate ACLR measurements on signals that have large crest factors, such as WCDMA, require special care. The MS2830A calculates the ACLR directly from the captured spectrum trace. However, the ACLR currently being measured is too high and does not meet the specification limit. To obtain accurate ACLR measurement results, it is very important to supply the proper input level to the spectrum analyzer first mixer. The mixer input level is adjusted by changing the attenuator setting, and optimum dynamic range is achieved by providing the maximum input level to the mixer that does not cause distortion in the mixer output. With the reference level fixed, the level of the WCDMA signal remains constant when the attenuator setting is reduced, but the noise floor drops. This indicates that the ACLR measured initially was due to the spectrum analyzer noise floor and not the device under test. As the attenuator is reduced further, the mixer input level becomes too large, causing internally generated distortion products that infiltrate the adjacent channel and make an accurate ACLR measurement impossible. A spectrum analyzer with a higher third-order intercept, or TOI, will generate less distortion products at a given mixer input level than one with a lower TOI. The availability of 2 dB steps on the attenuator enables the user to select an optimum setting that minimizes the measurement noise floor without causing excess signal distortion. After the attenuation has been optimized, the MS2830A offers a noise cancel function that automatically measures the spectrum analyzer average noise floor and subtracts it from the ACLR measurement results. This provides the additional dynamic range required for measuring ACLR on power amplifiers and other challenging devices. Next, we will measure a Narrowband P25 public safety digital wireless radio signal. P25 uses frequency modulation, and the CCDF of the signal reveals that the crest factor is approximately 0 dB. In other words, the peak power of the signal is about the same as the average power, which is as expected. Let's measure the ACLR of the P25 signal using the MS2830A. Notice that the measurement results remain the same as the attenuation settings are changed. This means the P25 signal and the noise sidebands are well above the spectrum analyzer displayed average noise level. With narrowband signals like P25, it is impossible to evaluate whether the measurement result is correct just by checking the attenuator settings. Now, we will enable the optional MS2830A low-phase noise function. And we can clearly see that this greatly reduces the close-in sidebands and improves the ACLR measurement results. The phase noise performance of the oscillator built into the spectrum analyzer is generally the most important factor when making ACLR measurements on narrowband or CW signals. A spectrum analyzer with excellent phase noise performance is needed to evaluate narrowband wireless communications devices with a signal bandwidth of less than several hundred kilohertz. The MS2830A offers the low phase noise, low displayed average noise level, high third-order intercept, and 2 dB step attenuator needed to address the most challenging ACLR requirements. It is the ideal spectrum analyzer for evaluating the transmission system of narrow to wideband wireless communication systems, devices, and components.